Hi everyone, Senan this side, and this video we're going to solve this Geeks for Geeks daily problem, which is maximum distance between the same elements. So before we get started, I just want you guys to know that the whole solution PDF is provided in the description below. So do check that out, which has everything from approach to complexity and the code itself. So yeah, let's get started. Okay, so the question is asking, given an array R with repeated elements, the task is to find the maximum distance between two occurrences of an element. You may assume that every input array has repetitions. So we know that at least there is one repetition. And let's look at this test case. This test, we see that for this 2, there is a distance of what? 2. So 1 and 2. So distance of 2. Between this and this, the index of this one is 5. This index of this one is 0. So 5 minus 0. The distance between ones is 5. So we only have two elements, and for 2 it was 2, and for 1 it was 5. So the max of them is 5, so we return 5. In this case, look at this 2 and this 2. So this 2 is at index 11, this 2 is at index 1. So 11 minus 1 is 10, and which is the maximum you could actually find in this whole array, right? So what is the time and space complexity expected? Big of n, okay. And these are the constraints. Now array size is 10 to the power 6, so obviously you cannot do a brute force approach, which is n square approach. You have to be a bit smart about this. So how are we going to do? So whenever we see a number which we have not seen before, I know this is the first occurrence, and if this number has the maximum distance, this particular index would be a part of my solution. This number would be subtracted. So the idea is this: I use an unordered map and initialize a max distance as int min. And now what I do is, for I, all the elements, I say if map has this element array of I, that means I have seen an occurrence before. So what I do, I reinitialize maxi to max of maxi and I minus this element, right? So this current I and minus when I first found that element. So that distance between them could be our maximum distance. Otherwise, if I have not seen this element, that means I've seen this element for the very first time, I initialize the value to array of map of array of I to I. And through this, you will be able to get the maximum value, and in the end, you return the max. I think this is quite obvious. So if you see, we are using unordered map, and the amortized time complexity is big of 1. That is what we are going to assume. So this is a big of 1 operation. This is a big of n big of n operation, time operation. So the total time complexity is big of n, and the space complexity is big of 1, because let's say our map could store all the elements, right? Let's say if it has all the different integers, it would have different elements. So yeah, the time and space complexity are matching with what is, and this is the whole video. Be sure to check the description for the PDF solution, and I'll see you in the next video.